This next question, comes from fall. So it's fall. Let's erase this one here. Fall 2023 problem 2. It's a question about you have a sphere with a cavity. So it looks like this. Here is the sphere. The sphere has radius capital R. This is the sphere. It has radius capital R. And then a cavity of a spherical cavity is carved out. And the spherical cavity has radius 0.75 R. Radius is 0.75 R. So what's the diameter? 1.5 R. It stands basically here. That cavity looks like this, right? That's the cavity.
Oh.
Yeah.
It's
It's
a big
a big one. Yeah. So this is, so out here there is nothing, right? Zero charge. So let me just draw. This is capital R, right? That's the radius of the big sphere. The center of the cavity is here. That's the center of the cavity. So let's say this is x equal to 0. What would this be?
X equal to D.
X equal to what? I'm looking in terms of capital R. 0.25 R. And you're right, yeah, because this distance is R, right? From here to here, it is R. And this distance is 0.75 R. Therefore, this is 0.25 R. So this is 0. Here is the x-axis. That's the x-axis, okay? So out here, outside here, there is a charge, capital Q, at position L. So L from the center of the sphere to here.
So in this case, we don't have symmetry, right? So we have to integrate.
But we don't have to. If you try to use this shape directly, yes, but we don't have to. So can you think of a way to avoid complicated integrals? There is
Do it.
I'm sorry, what's the radius of the small circle again?
a small sphere,
Yes, small
0.75 R.
75, okay.
So the small sphere is 0.75 R. I'm avoiding to write another line so it doesn't. So this is 0.75 R. Again, here it's empty. So can we think of a way
The electric field?
to find the electric? Yeah, we want to find the electric field somewhere outside. By the way, when you're outside, if you have a perfect sphere, it's like a point charge, right?
Yeah.
Yeah. So, yeah,
Opposite charge, right?
that's the idea. So, by the way, yeah, the charge density here is rho.
Oh, okay.
Charge density is rho. So since it's empty, so we will think of it as follows. One solid sphere of radius r and charge density rho, and pushed inside it, one solid sphere, radius 0.75 r, but charge density negative rho. Then the total electric field outside there will be the sum of those fields. let's call the big sphere one, and then the small sphere number two. And they want us to find the electric field at position L. Actually, no, they want us to find the total electric field at somewhere here.
Oh, so, but in terms of L,
So L will show up, yeah.
Three E.
oh yeah, it's too easy, sure.
So find the total electric field here. So let's do it. So for the big sphere, I will start with the big sphere. I will call it E1. So big sphere. You got E1 will equal to Q 1 over 4 pi epsilon naught times 1 over, how far from the center of this sphere to this point? It's x, right? It's over x squared. Right. And it's in the positive x direction. Now what's the charge on this big sphere? Rho, capital R, cubed, right? Four pi. So E1 is going to be rho, capital R cubed, over 3 epsilon naught, 1 over x squared, right? That's the electric field for the big sphere. Small sphere. E2 going to be Q2 over 4 pi epsilon naught, 1 over something squared. What would be the something squared? Yeah, the distance from the center here to this point is x minus 0.25 r, right? Would be x minus r over 4, right? 0.25 r is r over 4. Now Q2 is, what's the charge density of the smaller sphere? Negative rho. So we have minus rho times 4 over 3 pi. Yeah, the radius of the smaller sphere is not r, it's 3/4 r, right? Now we can do this the following way. So first of all, you got negative, and then rho. So notice here, what is 3 cubed? Which is 9. 27 over 3 is 9. So 9. And then you got r cubed. Yeah. And then here, yeah, 4 cubed is 64. Epsilon naught. And then this. That's E2. Okay. And then the point charge.
0.25 bars should be sometimes the center of the big sphere to X, but the center of the small sphere to X is S. It should be the right way.
For the point charge, it's gonna be E3. Going to be Q over 4 pi epsilon naught times 1 over something squared. How far is the point charge from here?
That's X.
Yeah, L minus X, yeah. But, let me see here. We have to put a minus sign in front of it, why?
It's from,
Yeah, because the electric field points that way, away from the charge. The minus sign is because of the location of the charge. So the total electric field, you just add them together. So, the total electric field,
oh.
I don't need to add, you can just add them together. Now, question B. Question B says, this was part A.
Okay.
This was part A. Question B is tricky. It's tricky as in if you understand it, it's easy. Otherwise, you would be doing hopeless integrals. Okay. So here's question B. Yes.
If you didn't give us like, the integral, like, like for some problems you give us integrals, right? So we can probably think if you didn't give us, then we don't have to.
Then it should be either an easy integral, or you're doing too much stuff.
Okay,
Yeah, too
okay.
much work. Yeah. So here's the question. It says, you see this charge would apply a force on the sphere. Right? What's the force on the sphere?
The same
Same force.
as the force of the sphere.
That's the key.
Yeah.
By Newton's third law. So if you try to find the force of the charge on the sphere, it's crazy, yeah, because it's the charge distribution. But you can find the force of the sphere on the charge by finding the electric field due to the sphere at this point and multiplying it by Q. So
E1, E2.
E1, E2, and you just need to change X to what?
That's the L minus. Oh, wait, sorry.
We want to find the field
Yeah.
E1, E2 at this point. So what should X be? L.
Yeah.
And X here is also L. Yeah. So
Yeah.
at X equal to L, we get E1 plus E2 will equal to the following. The E1 becomes this, rho R cubed, right? Over 3 epsilon naught times 1 over L squared. And then this one, minus 9 rho R cubed over 64 epsilon naught over X minus R. So L becomes, right? L minus R over 4 to the second power.
No calculators.
Yeah, okay. Yeah, and then so the force on the sphere is equal to negative the force on the charge, right? The force of the sphere is equal to negative the force on the charge by Newton's third law. The force that the sphere applies on the charge is the same as the force that the charge applies on the sphere. So that's going to be minus Q times E1 plus E2. I want to plug it.
If we have our E1 plus E2 doing that, or we are okay just to say E1 plus E2 in brackets, right? If you can clearly see.
Yeah, I
what
don't
E1
think
is.
so.
Okay.
How am I doing?